Hello friends, welcome to Kranthi Physics Tutorials. So in this class we have to discuss about Biot and Savart's law. So here Biot and Savart are the names of the two scientists. Okay, so Biot Savart law is the very important question in your moving charges and magnetism topic, right? So here what is the Biot Savart law? So first of all, before going to discuss about the statement of the Biot-Savart law, so now we can draw a diagram here. So here we consider a current carrying long wire. This wire carrying the current is how much? I. Okay, so even this wire can be in curved shape or straight shape, so whatever it may be, so there is no problem. So now, so throughout the total length of the wire is L. So here from X to Y, the length XY, but so we can take only small infinitesimal length here. We in this total entire length of the current carrying conductor, just we can consider a small current carrying element, so that it has how much length? DL, a small part, a small division of the current carrying conductor we can consider. So this current element DL is exhibits how much magnetic field at any point in its surroundings. So that equation can be derived by the Biot-Savart's law. Okay, so now we can consider a point P. We can consider a point P. So at a certain distance R, at a certain distance R from the current carrying element DL. So now R is here, R is the position vector, right? Here at point P, so the current carrying element DL exhibits how much magnetic field? dB. DL element exhibits dB magnetic field here. Now in this, if we can draw the current direction passing through the element, so like this. So this is the tangent drawn through the current direction. So then so the angle between the position vector of point P and the current direction vector tangent is theta. How much is theta? So now we will discuss about the Biot-Savart's law statement. So Biot and Savart stated that using this current carrying conductor, so the magnetic field around current carrying element, so the current carrying element here, that is DL, so the magnetic field around current carrying element, so at any point P, so that is how much? dB. It is directly proportional to the strength of the current I, and it is also directly proportional to the length of the current carrying element DL, and it is also proportional to the sine angle of between the tangent drawn to the position vector R. So but you must and should remember, it is inversely proportional to the square of the distance of the point P from the current carrying element, so that is R. So this is the statement of the Biot-Savart's law. So from this statement, so what we have to write the equation, so like this. So here dB is directly proportional to I, and dB is directly proportional to DL, and dB is directly proportional to sin theta. So but so dB is inversely proportional to R square. So now we have to combinedly write all these equations as one single equation. So that is dB is directly proportional to ideal sin theta by R square. Now so if we can remove the proportional, then we get proportionality constant, so that is mu naught by 4 pi IDL sin theta by r square. So where mu naught by 4 pi is the proportionality constant. So finally, what is the Biot-Savart's equation? So dB equal to mu naught by 4 pi IDL sin theta by r square. Here mu naught by 4 pi is the proportionality constant. So here mu naught is called as the permeability of free space. So permeability, so that means, so if any medium has how much ability to pass the magnetic field through it, so that much of ability value is called as the permeability. So we can denote the permeability by the letter mu naught. So in electricity, so we called it as permittivity and we denote it by the letter epsilon naught. But in magnetic field, so we called it as permeability, it is denoted by the letter mu naught. So same epsilon naught and mu naught, so both are similar, but epsilon naught is used in electricity, but mu naught is used in the magnetic field. So magnetism. So that you must and should remember, if anywhere so mu naught is there, so that will be considered as the magnetic field, and if anywhere we can see the epsilon naught value, so that means there is a electric field is there be considered. So here mu naught by 4 pi value is 10 to the power of minus 7 Tesla meter per ampere. So what is the value of mu naught? So 10 to the power of minus 7 into. So here what is the value of mu naught? So mu naught is equal to 10 power 7 into 4 pi. So that is the value of mu naught. Here mu naught is called as the permeability of free space. So in place of mu naught by 4 pi, if we can substitute the value of 10 to the power of minus 7. So this equation is called as the Biot-Savart's law equation. So very important. So the magnetic field at anywhere, so due to the current carrying element, so not for the total entire length of the wire, only for the due to the current carrying element, small length element dl, so that is equal to mu naught by 4 pi IDL sin theta by r square. This equation is stated by the derived by the Biot and Savart's two scientists. That's why it is called as Biot-Savart's law. So is it clear, everybody? So this is Kranthi signing off. Thank you.